In this tutorial, we will be discussing the band of stability and why some atoms decompose. Any element with more than one proton, any element that's not hydrogen, will have the repulsions between the protons in the nucleus. A strong nuclear force helps to keep the nucleus from flying apart. Neutrons play a key role stabilizing the nucleus. Therefore, the ratio of neutrons to protons is an important factor. For small nuclei, down here, Z less than 20, remember Z is the atomic number, which is also the number of protons. The stable nuclei have a neutron to proton ratio close to 1 to 1. As nuclei get larger, it takes a larger number of neutrons to stabilize the nucleus. The shaded region in the figure, the so-called belt of stability, shows the nucleides would be stable. Nuclei above this belt have too many neutrons. These nuclei tend to decay by emitting beta particles. Nuclei below this belt have too many protons. Nuclei here tend to become more stable by positron emission or electron capture. There are no stable nuclei with an atomic number greater than 83. Nuclei with such a large atomic number tend to decay by alpha emission because you are decreasing more at one time. Large radioactive nuclei cannot stabilize by undergoing only one nuclear transformation. They undergo a series of decays until they form a stable nuclide, often the nuclide of lead. So, for instance, uranium here first goes through alpha, and then it changes by increasing the atomic number. And then it decreases quickly again by more alpha decays, and then goes back and forth. Nuclei with 2, 8, 20, 28, 50, or 82 protons, or 2, 8, 20, 28, 50, 82, or 126 neutrons, tend to be more stable than nuclides with a different number of nucleons. Nuclei with an even number of protons and neutrons tend to be more stable than nuclides that have odd numbers of these nucleons. Alright, so we're going to do a couple practice problems. Predict whether krypton-85 is stable or radioactive. If it is radioactive, predict the mode of radioactive decay in the daughter nuclide. So first we're going to look at whether or not krypton-85 is actually radioactive or decay. In order to do that, we're going to look at the neutron to proton ratio. So krypton-85, when we look on the periodic table, we see that krypton has the atomic number of 36, which means Z is equal to 36. So we take 85 minus 36, the mass number minus the atomic number, to find the number of neutrons. We want to figure out what the ratio is. So we're going to take the neutrons divided by the atomic number to be 49 divided by 36. That comes out to be 1.38. That's the ratio. Most stable isotopes having a Z between 20 and 40 have N over Z ratios between 1 and 1.25. Notice that we have 1.38. We are above that ratio. Therefore, we expect krypton-85 to be radioactive and undergo beta decay because of the numerous neutrons. I have 1.38 here. This should actually be 1.36. That was a typo. Okay, pardon. Therefore, expect Krypton 85 to be radioactive and undergo beta decay because of its numerous neutrons. Remember, beta is 0 over -1. Decay means that it's going to be given off. By doing that, you are actually increasing your Z. So if radioactive, predict the mode of radioactive decay and the daughter nuclide. So we already said it was beta decay because we want to increase this bottom number. So 85 goes to 0 plus, well, the number comes out to be 85 again. And then the bottom number, 36, is equal to -1 plus x. X then becomes 37. This gives us a ratio now of 1.32. We're still not at that 1.25 range, but we are getting closer. Alright, let's go on to another question. Predict the kind of radioactive decay that magnesium-22 undergoes. Once again, we have to look at the ratio. Magnesium-22 has the atomic number of 12 and the mass of 22. We figured this out by looking on the periodic table. As a result, that means we have 22 minus 12, we have 10 neutrons. From here, we have N and Z, we can figure out our ratio. Calculate the N over Z ratio, 10 divided by 12. That's 0.83. From the value of nuclear stability plot, from 1 to 20, that ratio has to be 1 to 1. It needs to be somewhere around 1. And we have 0.83. This means that magnesium-22, this ratio is low. We need to convert protons into neutrons to make it closer to 1. Therefore, it's going to go into positron emission or electron capture. We're going to decrease the bottom number in this process. And that is the band of stability and how to predict radioactive decay.